conical flask. White. A conical flask. So here is a conical, we have used a beaker because we don't have a conical flask. Okay? So in here there's a base called what? Calcium hydroxide. Are we okay?
Yes.
It's calcium hydroxide. Now, a pipette, the way it looks like, long tube made of glass. So when we are using a pipette to get a solution, we use our mouth. So you put it in a solution and then you suck it out. Up to 25 cubic centimeters. Then you drop it in a conical flask. Okay? Are we together? Yeah. Now, it was also saying, add 2 or 3 drops of indicator to calcium hydroxide using a dropper. Now, the indicator that we have here, pass me that one. No. Yes. So the indicator that we have used is this one. It is called what? Phenolphthalein. It's called change.
Phenolphthalein.
I know someone here doesn't know. So we know you. So this one, I've just made it in a solution form. So we put it in a solution. Now they are saying we should add this indicator to the what? To the base, which is calcium hydroxide.
Yep.
So since we don't have a dropper, it is still okay if we just pour. So we just pour a small portion like that. You can see that the color has changed.
Yes.
What color is this? I know how it looks like pink, yes. That is what pink? Hot pink. It's hot pink. You have to be hot for you to know this thing. Hot pink. Yeah. So it has changed color after adding the indicator.
Yes.
Yes. Now, fill the burette to 0 reading with dilute hydrochloric
acid.
The burette is this one. Are we together?
Yes.
So, at the topmost level here, there's 0, right?
Yes.
And you can see numbers are increasing as we are going down. Yes. So there's 0 here. So I was putting the acid into the burette until it reached the 0 mark. Are we okay?
Yes.
So I have to make sure that it is held tight. But as you are adjusting this thing, you make sure that you are careful because it's made of glass. So if you use a lot of force, you break it. So you have to be careful. So we are still following our instructions from the board. Place the conical flask on a white tile. Where is the white tile? This one here.
Yes.
We are not looking at the bottom kind. The top, what?
Yes.
White. So we place it like that. Then, white tile, but X in a mark. And you stop the experiment when you see the X down there. I don't know which was X we are trying to see. Add dilute hydrochloric acid from the burette to the what? To calcium hydroxide in the conical flask while swirling until the mixture just changes the color. What is to swirl?
Swirl.
To move it about. Yeah. You'll be moving it about like that. So we are on this instruction. We have to add now the acid into the what? Into the base. You see my left hand like this. When you are handling this, your left hand like this. Like this. Like this.
Yes.
I'm holding the what? The like this. Then, after holding this with my left, my right hand will be holding my base, and then I lift it up like this. So I'll use my left hand to do what? To open like this. Under normal circumstances, where it is oozing out uncontrollably. No, but just see enough drops like that. little by little, and I'll be swelling as the experiment continues. So I'll be allowing it to swell like this. Now, because of time, I can just open it enough. So I have to make sure that my eyes are where? In the base. I only have to stop when the base changes its color. Yeah. When the base changes its color, that is when you have to stop. Is it chinchi? Chinchi? So it has now changed the color from hot pink. I still remember the color. Hot pink to what?
Colorless.
Colorless. But don't write hot pink, you just write pink. Just pink. Don't start writing hot pink. Yes, so it has changed the color from pink to what? To colorless. Are we okay? So now, what we have formed here is a soluble salt. Why are we calling it soluble salt? Remember the first one, we had particles settling at the bottom. Right? That's why we are calling it insoluble. But here, can you see any particles at the bottom?
No.
They are not particles, meaning the salt that is inside is what? Is the soluble. Are we okay? Uh-huh. Mwah. Yes.
How can you tell that there's a mix of calcium hydroxide and hydrochloric acid?
Where? It's our way. It will give you just like that. When we give you, we will make sure that we label what you have. Because in the lab, we can give you anything. Yeah, so at that particular time, because when there's calcium hydroxide, you dissolve it, it looks colorless. Let's say sodium hydroxide, you dissolve it, it still looks colorless. So it will be our job now to indicate for you, to say it will compare calcium hydroxide now sodium hydroxide. Now, from what you were given here, from the titration result, we can know the exact volume of hydrochloric acid needed to react with the 25.0 cubic centimeter of calcium hydroxide. What they are telling you now is you can know the volume of the acid that is required to neutralize this one to form a salt. How do you know the volume? Remember that when we were starting, it was at what? Zero. Then, after the practical, after the reaction took place, you begin to look at where the acid now is remaining. From where I am, I can see that it is 22. It is 22 cubic centimeters. So in your answer, you are going to write to say 22 cubic centimeters of hydrochloric acid was used to do what? To form the salt. Are we okay? 22 cubic what? Centimeters of hydrochloric acid was used. Are we together? You see now the difference between a soluble and insoluble salt.